Hello children, in this video I will explain about the properties of integers, and these three properties I am going to explain: closure property of integers, commutative property of integers, and associative property of integers. But before that, you should know what is a property. A property is a certain rule that holds if it is true for all the elements of a set under the given operation. Let's look at some examples so that you can better understand what they are. Now, the first property is about closure property of integer. The set of integer under the operation of addition, that is also addition, that is also integers. It means when I will add any two integer, the sum will be also integer. Here are few examples, like 13 plus 23, that is 36, which is an integer, and minus 23 and minus 12. When I'm adding this according to the rule of integers, 23 and 12 is 35, as they are having the same sign, common sign. That's why I will put negative sign only. So that is 35, which is also an integer. When it is true in all the cases, either it is positive or negative, then we will say that the integers are closed under addition. Now the next is closure under subtraction. The set of integers under the operation of subtraction is also integer. See, when 23 is subtracted from 73, that is 50. So 50 is what? 50 is an integer. If I'm subtracting 23, here is the subtraction sign, from negative of 73, then I'm getting minus 96. Here is the process which I have already explained in my previous video. Minus 73, and I will make I will change this 23 as negative, and the operation I will convert it into positive. So minus 73 and minus 23 both are having the common sign, so it will be 96, and I will put the common sign which is negative. So negative 96 again. While doing the process of subtraction, I am getting 96, negative of 96, which is again integer. So we can say it is true in all the cases. So integers are closed under subtraction. When we are taking in the case of multiplication and we are multiplying two integers, here 13 multiplied by 23 and the product is 299. And in second example, when I'm multiplying minus 23 by minus 12, the product is 276, and according to the rule of multiplication, when negative and negative common sign is there, like sign is there, then the product will be positive. So here the product is again integer, so it is true in both the cases. So what we will say, that integers are closed under multiplication. But when we are taking the example of division, here is the division of two integers. When 25 is divided by 5, fine. Here we are getting 5, which is an integer. When I am dividing this negative 25 by 5, then again I am getting minus 5, which is again an integer. But when I am dividing 5 by 25, 5 by 25, 5 ones are 5 and 5 5s are 25, so I am getting 1 upon 5. And 1 upon 5 is not integer. So it is not true in all the cases. In this cases, we are getting integer, but in this case, we are not getting an integer. Again, one example, 13 divided by 2, 13 divided by 2, and it cannot be converted to the reducible form. That's why this is also not an integer. So it is not true in all the cases. That's why we can say that integers are not closed under division. Here is the summary of the closure property. Integers are closed under addition, subtractions, and multiplication, but they are not closed, or we can say they are open under division. Now, the next property is commutative property of integers. Commutative property under addition is if we add two integers in any order, the sum remains same. So addition is commutative for integers. Or we can say then when a plus b is added in other way, or when we are changing its order, b plus a, in the sum there will be no changes. Here we can take the example 3 plus 23, which is 26, and 20 plus 3, when I'm changing the order a plus b to b plus a, then again I'm getting this 26 only. Here minus 41, when I'm adding negative of 32, this is also negative and this is also negative, and according to the rule, when I'm adding, I'm getting 73, which is negative 73. And here again, when I'm 32 to minus 41, negative of 32, again the answer is minus 73 only. So we can say if we add two integers in any order, the sum remains same. So addition is commutative for integers. Now, next example about commutative under subtraction. And we can see commutative under multiplication also. Just like addition, when we are taking two integers, 7 into 9, which is 63, 9 7 ja, again 63. Both are same. So, and here also 12 8 ja, and here is 8 into 12, which is 96, negative of 96. It will become positive. And this will also become positive according to the rules of multiplication, but the product is same, so they are also multiplication. In multiplication, integers are commutative. In addition, it is commutative, and in multiplication also it is commutative. But when we will take the example of subtraction, and if we subtract two integers in any order, here if I'm subtracting 23 from 3, I'm getting negative of 20. But when I'm subtracting 3 from 23, I'm changing the order. Here it is the subtraction sign. 23 is not negative. I'm subtracting 23 from 3. So I'm getting minus 20. And here when I'm subtracting 3 from 23, I'm getting 20. This is positive. But here in left hand side, it is negative. They are not equal. It is not true in this case. And if I will see here also, this is also not same. That's why we can say in subtraction is not commutative for integers. It means when I'm subtracting a minus b and when b minus a, they will not be same. Now, the next is commutative under division. Just like in subtraction, when we will observe this, if we divide two integers in any order, the result will not remain same. So division is also not commutative for integer. Here is one example. 12 divided by 3. We know 3 fours are 12. When I'm dividing 3 by 12, I'm getting 1 upon 4. So both the questions are different. So we can say when A is divided by B, or B is divided by A, when I'm changing the order, the answer is not same. That's why we can say division is not commutative for integers. Now next property. Here is the summary again. Addition and multiplication is commutative for integers, but subtraction and division is not commutative for integers. Now the next property is about the associative property of integers. Associative under addition. If we add 3 or more integers in any order, the sum remains same. If I'm adding 22 plus 13, or we can say a plus b plus c, or c plus a plus b, there will be no change in the sum. Answer will remain same. Here we can see two examples. Here 22 plus 13, which is 35. When I'm adding 35 plus 7, I'm getting here 42. You can also add. Now here, but in right hand side, when I'm adding this 7 plus 22, now here the 7 is C, and I'm adding this 7 plus 22, C plus A. You can see C plus A. When I'm adding, I have changed the order. 7 plus 22, which is 29. And when I'm adding 13 to 29, I'm getting 42. 42, 42. It's mean when I'm taking these integers and changing their order and adding, the answer is same. The sum is same. And here one more example, minus 4 plus minus 13. Again, according to the rules of additions of integers, when the two integers having the common sign negative negative, simply add them. 13 plus 4 is 17 and it will be negative 17. And when I'm adding plus 11 into it, then according to rule, I will get minus 17 or 11. So 17 minus 11 is my 6 only. And since 17 is big, so I will put minus 6. Here, according to this rule, when we are changing the order, here is the C and here is the A, C plus A. When 11 and 4 both are having the different sign, and according to the rule of addition, when they are having the different sign, simply subtract them. So 11 minus 4 is what? 7, and 11 is having the positive sign, so 7, and 7 minus 13 is again what? Minus 6. Minus 6, minus 6. You can also check according to the rules which I have already explained in my previous video. So here it concludes there. If we add 3 or more integers in any order, the sum remains same. So addition is associative for integers. If I'm taking another example of associative under multiplication, when I'm taking 3 integers and I'm multiplying them, 13 into 7 into 2, and when I'm changing the order, there is no change in the product will remain same. We can see 13 into 7, which is 91, 13 sevens are 91, multiply by 2, which is 182. Fine. And when I'm multiplying this 2 into 7, which is 14, and when 14 is multiplying by 13, which is again 182, 182, 182. In the product, there is no change. So we can say, and if I will put this negative sign here also negative sign, then also the answer will remain same. So it is true in all the cases, whether it is positive or negative. Then we can say multiplication is associative for integers. Now see next example, associative. Now two cases are remain, subtraction and division. If I'm taking the case of subtraction and division, if we subtract or divide 3 or more integer in any order, the result will not be same. So integers and subtraction are not associative for integers. Here are two examples. This is of subtraction and here is of division. Now see the subtraction. 5 minus 7 minus 2 is not equals to 2 minus 7 minus 5. Here I have changed the order. That is not equals to, let's prove it. 5 minus 7, so it is minus 2 according to the rules of subtraction. And when minus 2 and minus 2, naturally it will be minus 4. Okay. And here 2 minus 7, 2 minus 7 is what? Minus 5, because 7 minus 2 is 5, and since 7 is having the bigger sign, 7 is the bigger number which is negative, so it will be minus 5. Now again the minus 5, and according to the rule 5, and this is also 5, and I will remove this bracket, then minus 5 and minus 5 both will be added and it will be minus 10. Here is minus 4 and here is minus 10. That's why they are not same. In division also, when 12 is divided by 3 and again it is divided by 4, 12 divided by 3, 3 4s are 12, and this 4, and when 4 is divided by 4, naturally it is 1. But when I'm changing the order, 3 divided by 12, 3 divided by 12 is what? 1 upon 4. When I'm dividing this 1 upon 4 by 4, it will be not equals to 1, just like in left hand side. So we can say division and subtraction are not associative for integers. Okay. Now, in the next video, I will explain you about the distributive property of multiplication over addition. Hope you like this video.